Please welcome Philomena Zimmerman.
Today to talk to you about where the Department of Defense is with its digital engineering activities. I know from listening in to segments of ACE that you have been offered many challenges and many opportunities to understand where we can go digital and where we can improve the engineering of our systems. And it doesn't have to be just for the Department of Defense. It could be in any area. So I'm thrilled and humbled to be able to talk to to the users, to the doers, because out of your doing is where all this magic happens. Out of your doing is where we're going to be able to achieve the next generation of capabilities for the United States. And so I'm humbled and I appreciate the opportunity to be here. I want you to take away a couple things from my talk today. Number one, tools and data don't have feelings. And so hopefully you're chuckling a little bit about that. I like to have fun whenever I do these types of talks. And what I mean by that is that if you can manage to uncomplicate what you are doing by separating the content from the tool, then I think you'll kind of have more space in your brain, if you will, to think about the creative ways in which you can use the tools and creative ways in which you can use the data. That puts the burden on you and your integrity to make sure that you're using them properly. But don't let the application confuse the very real capabilities that the tools have, right? Try to keep those separate. And then the second thing is to be very open-minded. When we talk about digital engineering and digital engineering our systems, of course, from a Department of Defense perspective, I tend to think about those big things, the F-35s and the next ground combat vehicle. But it doesn't have to be that large. What we've learned over the years of working with many different agencies is that oftentimes what we are doing is we are re-engineering perhaps patient care processes at the VA, or perhaps next generation flight systems for the FAA. The digital, like any capability, doesn't care what it's being used for as long as you can represent it properly. And so that's what I hope to give you today. And then finally, because we are at a very major tool vendor conference, here's my final desire. Open up a dialogue with ARIS. And for ARIS, open up a dialogue with your customer base. And here's the reason why. If we, as users, only go as far as our tools will allow us to go, then we're no longer in control, right? And I don't mean that pejoratively. We have to be able to help ARIS understand what it is we need to do with this marvelous world of computational capabilities. And ARIS can imagine what it's like, but again, you are at the magic point, right? You are at the cutting edge of the application. So open up that dialogue with ARIS, help them out, and they will in turn help you out. So here's what I want to talk to you about today. If, in case you haven't been on this journey with us, here's where we've been with digital engineering, and here's how we got there. And the digital engineering strategy is more than using just the digital tools, right? You can't just be given a tool as capable as ARIS Innovator and then expect the magic to happen, right? You're not given permission to not think. As a matter of fact, I have a sign in my office that said, "Think, it's not illegal yet." And we have to be careful about this, and we have to look to the left and to the right, or up and down, depending upon what your orientation is, to know that there are things that we have to communicate, and there's a cohesion that working in a computational world gives us that we need to take advantage of. I want to talk to you a little bit about how digital engineering fits into some of these larger system engineering efforts, and indeed within the Department of Defense, how we're trying to refresh our engineering practices. And then where are we in the Department of Defense, and who are we cooperating with? So let's see. Going on to the next slide. For those of you who don't know, I work in the Undersecretary of Defense for Research and Engineering, engineering being the key. And we have two major areas that we continue to work on since 2018, when the National Defense Strategy was released. Ensure technological superiority for the U.S. military. I'm proud to say I'm the mother of a soldier. My son returned to the United States, as a matter of fact, just yesterday from his deployment. And so I want to make sure when he and all of his comrades, his buddies, go out into the field, regardless of what they do, that they're equipped with the best. And then for us, we have to bolster modernization. How can we improve our engineering practices? How can we improve our engineering support to acquisition, to training, et cetera? And how can I get new capabilities in the hands of the warfighter faster? Those are core to our mission in research and engineering. You'll hear some very good work going on in hypersonics. You'll hear some really good work going on in cybersecurity. What you don't hear often about is what I want to talk to you about today, and that's modernizing those engineering practices and the way we go about doing business. This slide, I apologize. It works out better in PowerPoint, but that's okay. So if it looks a little clunky, just bear with me. I want you to focus on the middle piece. Digital engineering starts from a very humble definition, right? And again, get simple, separate content from capability, but get very simple in your thinking in order to accelerate and to broaden your ability to apply the tools that you're using to some of the challenges you've heard in ACE 2021. A model is just a representation of reality. That's all it is. It doesn't have a specific format. Many people wish it would. It doesn't have a specific set of capabilities. It needs to represent the reality that you need to represent. So if you need to represent the process of picking up a weapon, or if you need to represent the physical coordinate system of the center of the Earth in a particular coordinate set, those are models, right? With that expanded thinking, I'm going to apologize because now you're not going to be able to turn around without seeing a model, right? The spreadsheet that I do my family budget on is a model of my family budget. I'm sure the same will be true for you, but it's not any more than that. Don't worry about validity. It's important when you use it, but not to extend model into things like digital twin, into things like digital threads. Digital engineering comes from and synchronizes with modeling and simulation on this very definition. The modeling and simulation community, traditionally in the Department of Defense, believes that modeling and simulation is an enabler of warfighting capabilities. Well, that take model out of that, and now we have that the model is an enabler of warfighting capabilities. Absolutely true. Again, whether you're doing a process model, whether you're doing a formula as a model, or whether you're doing a data set or any combination of those three and others, you have a model. And that's very important to understand. It is not reality, but it needs to represent that level of reality that you need in order to do your job. And then the final piece with this is actually one of two final pieces, is that the Defense Modeling and Simulation Coordination Office has shifted. In September, it was moved into the group that I lead called Engineering Tools and Environments. And we changed the focus from just coordination on modeling and simulation activities to technical leadership. Because what we found was that under the simplistic view of model, you've got now an expanded user base, there are many things within the modeling and simulation community that are very valid for digital engineering users. There are many things that with a refresh can apply to some of the digital engineering gaps that we have. One of my favorite ones to look at is trust. The modeling and simulation community has had a focus on validation, verification, and accreditation. Digital engineering, because it speaks about the use of computational capabilities, the use, right? That's what this is. This is about using your capabilities. We have more of a notion of trust. Validation and verification is a part of trust, but it may not be the only piece. So how can we refresh what is in the modeling and simulation community, do no harm to that community's ability to use it, but also expand the notion? And so all of these combine into digital engineering. We have this marvelous tool set that comes to us from the traditional modeling and simulation community. We have this marvelous, we're at a nexus where we have an incredible amount of computational capabilities that we now have at our fingertips. And now we have a demand signal like we have never had before. So with that, I'd like to go on to the next slide. And so for those of you who don't know, who haven't yet heard the basis for the things that you've been talking about in ACE, digital thread, digital twins, applications, et cetera, it all came from this fundamental strategy that we wrote. Well, actually, we wrote it over a series of years, but it was released by the Undersecretary of Defense for Research and Engineering in June of 2018. So we have a small anniversary coming up. And when you look at it, it's 20, I think I opened up the original strategy. I think it's like 24 or 27 pages. It's not very big. And if you are a practitioner in this community, you should read this document and go, oh, of course, right? They wrote down the obvious. And that's what I'm here to tell you. We get credit for writing down the obvious, but what we did was we coalesced what you might consider to be the obvious things into something that now almost emphasizes that unspoken permission that you have as an engineer to use all of the tools at your fingertips. I often point out to people in the Department of Defense that there's nothing in acquisition policy. I'm acquisition qualified, so I tend to think a lot of my world from that mindset. There's nothing in acquisition policy. There's nothing in refresh that says you can't use computers. And the strategy isn't a policy. It doesn't force people to use computational capabilities, but it sort of brought it to the top and now encourages people to use it. And so here's what the digital engineering strategy says, and I'm going to paraphrase it. The first goal says if you're going to use models, you need to tell people that you're using models. Well, that sounds pretty obvious, but to our acquisition decision makers in the Department of Defense, it's not as obvious as we think it is. That means you need to use models to support everything you do. And I'll talk a little bit about one of the efforts that we have ongoing with the acquisition and sustainment group to bring some of these enablers into their acquisition community. But you need to tell people that you're going to use it. That actually leads to goal number 2, which is an authoritative source of truth. Your model, your models, your congregation of them becomes the authoritative source of truth that should govern whatever you're using them for. Not meant to be a circular argument. I apologize if that's what you took away from this. But I want to let you know that at some point in time, the information that you use, the models, the representations of reality that you use to do your job, to make your decision, govern the jobs you are doing and the decisions that you are making. Again, it sounds very simple, but it turns out, especially in the Department of Defense, it's very hard to find those chartering letters that give anybody the authoritative source of truth. And more often than not, we'll have people who'll stand up and say, my model is the best. And then, a week later, you'll have somebody come with a chartering letter that says, no, my model is the best. So I wanted to go back to that thing about separating the content from the tool, right? Separating the use from the application. I'm not, in Office of Secretary of Defense, I'm not going to tell you which one is better. It has to be governed by how you want to use it. The third one says to incorporate technological innovation. And this is where I think you actually have a role to play in this. And this is why I think an open communication with ARIS and all the tool vendors is so important. If you have something that you want to do in a computationally consumable way, and you have a tool that won't quite get you there, should you go off and buy another tool? Well, I don't mean to cause everybody in ARIS for their jaws to drop. That's not at all what I mean. If you've invested in a method through your tooling to do it some way, then wouldn't it be easier if the tool could be extended? Again, the tool vendors working in this world are almost as new to this as we are as users. And so without them going out and surveying the entire landscape of users, whether they're using their tool or not, the best way to increase the capabilities that you as the users have at your fingertips is to have that open conversation. And that's how we're going to get technological innovation in here, right? We're not going to get it by stopping using computational capabilities. That's absolutely not going to happen. But what do we need to do? What additional truth do we need to bring? What additional validity? What additional application areas do we want to use this in? That's what goal number 3 is about. Goal number 4 is the one that, and I apologize if you've heard this before. This is where this one almost didn't make it in. But apparently, having computers on desks is not a universal truth. And so we put this one in here. It says, if you're going to use and computing infrastructure, you have to have computing infrastructure. This one actually has gotten a lot of attention very recently from R&E leadership, to the point that we are now being asked whenever we talk about wanting to do something computationally, whether you call it digital engineering or not, it matters not to the Department of Defense. If you want to do something computationally, we are being asked to let them know what the cost of it is, because leadership now knows that this capability comes with a cost, and they also know that the capability that gets provided by doing things in a computational fashion is far greater than the investment that it's going to take to keep it running. And then finally, if you're going to do things in a computational manner, if you're going to do things in digital engineering, if you're going to use digital twins, you have to teach people how to do them. And I would be very careful in this area. I tend to represent the people who are in the latter 10% of their career, perhaps. And so I will speak about it from an age perspective, but I don't think it's an age issue. If you have people who absolutely don't want to learn a new way of engineering, don't force them. Because the value that I believe they bring to your situation, to your use, is far greater. Pair them with somebody who loves to model, but maybe doesn't understand where this subject matter expert is coming from. Maybe doesn't understand the area that the subject matter expert works in. You'll achieve a couple things. You will allow this subject matter expert to be able to see what they do inherently, what they do as a part of their being, come to life. But you'll also be able to transfer some of that knowledge to the modeler. It can't help it, right? And so I would ask you to think about, again, maybe with a little bit, maybe this isn't a technological innovation, maybe it's a behavioral innovation, but think about pairing people rather than forcing people. You get more flies with honey than you do with, with a fly swatter. But I think it's deeper than that. I think we have an opportunity to share knowledge and bring experts to the table that wouldn't ordinarily be comfortable doing that, and you can do it without forcing them to learn something new. So where do we come from, right? So this is the wrong slide. Defense Science Board recently did a study, gaming experimentation, modeling, and simulation. And they had they did a whole section on digital engineering as an enabler. And here are some of the things that you can see where there's measurable benefits from implementing digital engineering. Of course, I don't need to tell you about that, right? You're at the conference, right? You get it. But if you need to be able to convince management or leadership or your customer, there are some examples out there, right? And they're valid. And they actually are only partially related to the Department of Defense. And of course, if you need more contacts, just reach out to me. I'll give you my contact information at the end, right? We'll find those people. We did a paper across 5 government agencies, NASA, of course, the Department of Defense, FAA, DHS, and Veterans Administration. Now, there's quite a mix. Where we all worked on what we thought the benefits were and how to convince management. So we have that information available to you. But here's what the DSB found, right? And here's also from the DSB. Imagine, and again, I apologize, we tend to be acquisition focused. The DSB is it's an R&E body. Acquisition decisions, what are how could this possibly be? But we don't need to make acquisition decisions necessarily. And you need to think about a large spectrum of decision making here. These are not necessarily buy decisions, but these are decisions within the acquisition process, right? In acquisition, I always tell people your job is to have a spine and your job is to make decisions. Again, kind of trite, but really how you want to make decisions with the best information available. So if you have representations of reality that are the best that you have, then why not use them, right? Joint training. Let's step out of acquisition, right? Joint training has been conducted by simulations for years. A simulation is a model executed over time, and a model is just a representation of reality. So we've actually been doing this for quite a while. Digital engineering, actually, I like people to think about it, and this is particularly true of the digital twin. The digital twin represents a framework for communication. It is the phone line, right? Again, I said I'm in the latter 10% of my career, but it is that wired phone line, right? It is what you communicate through. It is not I want to repeat that. It's not what you communicate. It's what you communicate through. If you want to talk to a different engineering discipline, you talk to them through your digital artifacts. And the digital twin is one of them. Digital thread is another one. Different because they have different applications. And it's more than just the information about the system. It's analytics. It's processes. And it, in and of itself, can be housed in such a way that you can protect your intellectual property. And here's another thing that I always tell people, right? When you work in the digital world, Netflix protects their property. Why can't we? Right? Here's maybe a technological innovation. I apologize. Don't send me hate mail. But maybe the intellectual property could take a lesson from our movie industry or our music industry in how they license, in how they put, for lack of a better word, timers on the expiration of your rights to content, right? Maybe there's answers there. I would also offer that because digital engineering works on models, that maybe we can use the model concept to help us understand exactly what is intellectual property. Hey, oh, I'm sorry about that. I live in Maryland, allergies. But maybe what we can do is we can use the construct of a model to be able to better identify exactly what is intellectual property, right? It's not just about how do I protect my intellectual property, but how do I identify it, right? All of that is part of your digital engineering framework. Again, computationally consumable representations of reality, right? The world is your oyster. I mean, I need to come up with a better computer term for that. So anyway, and I apologize. I know that there are things coming up in the chat. I want to get through this. And if I have time at the end, I will try to go through it and answer some questions. So digital engineering and practice, right? Again, digital engineering is the what. That strategy, by the way, when you print it, it looks really pretty. But the digital engineering strategy on the left is the what you need to do, not the how. Because the how is very dependent on how it is used, how it is employed, what tools you're using. If you use Eris Innovator or you use some competing vendor's tools, your digital engineering might look a little different. That's okay. Can I still communicate back and forth with my customer? Can I still interoperate with the system that's next to me that is maybe using a different tool? Right? What do those standards look like for interoperability? And here's another piece that I have. And again, remember, I'm the mother of a soldier. When you work in engineering like this, nobody's shooting at you, right? At least not physical bullets. So if we need to take the extra time to learn how to translate, export to and import from some vendor neutral third-party format to increase communication, maybe we should do that, right? There are standards groups that I participate in. They're probably different from the standards groups that you participate in. But maybe we need to understand that. Maybe as users in particular areas, I apologize, I'm all military, helicopter versus fixed wing. Maybe there are rules of the road. Maybe there are formats. Maybe there are frameworks that make more sense to me than to somebody else in the rotary wing community. Nothing is stopping you from getting together and working that out, right? Believe me, there is a demand for that. And I also apologize if you can hear it for the grandfather clock in my background. I forgot to stop it. So drive implementation from the user standpoint. Leadership commitment, right? Wouldn't it be awful if you spent all this time doing something digital and your customer said to you, that's really great, but I really want to see the physical artifact before I make a decision? Well, that would be good to know. And how do you make them more comfortable with their commitment to digital? Engage your workforce. Find out what they're comfortable doing. Find out what tools they need. Find out what tools they use. Find out what interface mechanisms they have. Find out what standards are important to them, right? Digital engine, I talked about continuum, right? You need to have a continuum where your model, your representations of reality evolve as your reality becomes more clear, right? Well, you also need to understand that yours isn't the only reality going on, right? So engage your workforce. Find out where they're comfortable. Resource allocation. I talked about this as part of Goal 4, right? You have to resource this capability. Almost nobody in the United States anymore thinks about twice for paying $800 for the latest Samsung phone. Why is that decision any different from paying $2,000 to put a laptop or a tablet on somebody's desk to give them the capability to achieve the engineering rigor in what you're designing, right? They aren't really different, right? Budgets are different. Maybe the decision number is different, but the anxiety shouldn't be any different. And then measure results. And I don't mean measure how many people you have trained, although that's important. What I mean is how effective are your practices? How applicable is what you want to do to what you have to build? How applicable is the tool that you've selected to what you have to build? Remember that open communication with your vendors. And so here we are, this is a quote right from Dr. Griffin, and I've already talked about this. Digital engineering strategy is the what? You have to figure out the how. And I always tell everybody, I know how to model. I'm not really good at it. Unfortunately, I don't get to practice it as much as you do. So the how, I would probably be a really poor representative to say how you want to do it, but you don't need to have an expert to do it either. Right? I know how I model. I know what my techniques are. I know what works for me, right? Find out what works for you and your team. The nice thing about computers is that, it's easy to transform losslessly one format into another. It's not very hard. You don't need to do it by hand. Isn't that marvelous? So there's all sorts of examples of this that existed before the term digital engineering. So take advantage of that. And where are we in collaboration? I run a digital engineering working group that I'm trying to turn into a larger community of practice. And this is important. Do not just say, oh, we're going to go get in Phil's digital engineering working group. Because this is not about strap hangers, right? This is about making the community of practice responsible for making progress. I'm building a digital engineering body of knowledge you'll see that in the second to last bullet, for the digital engineering user community in the Department of Defense. Doesn't mean it's the only body of knowledge out there. As a matter of fact, there's probably like 5 other ones, and that's okay. If we conflict, we need to work it out. If you notice a conflict, you need to tell somebody. Be active. You guys are where the magic happens. You are responsible for making sure that challenges are known and challenges are solved. I have Tiger teams working. I have one on authoritative data, actually, that's now going to get connected up with the chief data officer in the Department of Defense. Systems Engineering Research Center is one of a few areas where a group of universities have banded together. In this case, the CERC is, I think, 22 affiliated universities. They have banded together to do research in digital engineering, right? And the research doesn't have to be immense. They're doing one on what does a minimum viable product look like for getting started in digital engineering. I hear people say, well, my digital engineering cost is exactly what my systems engineering cost is. Well, that's an interesting statement, but not proven. Why? Here's something else to think about. If you have a new capability like computational capabilities, You will only go so far if you employ a new capability in the same process. Imagine a world where you could reset the process based on the capabilities that you have to put together. That is, in essence, one of the things that we're doing with the system engineering refresh effort done under Ms. Nadine Geyer, who's a peer of mine. She's actually looking at what do those processes look like now that we have enablers like digital capabilities available. So think about that, right? In COSI NDIA, this is the one that I think is just immense, right? In COSI and NDIA are not something, these are not government bodies, right? One is a professional society, the other one is a group of defense industry companies, right? Very commercial. They've banded together and they've formed a digital engineering information exchange working group where they're trying to understand things like viewpoints on models and what do we need to say to each other? What does the lexicon look like? What are the set of standards that may have nothing to do with digital engineering, but are still applicable? Again, separate the tool from the use, right? Awesome body. If you want how to get contact with them, I can certainly get you in contact with the leads. Sean McGurvey from Applied Physics Lab at Johns Hopkins, Celia Tsang, and Tamara Hambrick. Tamara's from Northrop Grumman. I apologize. I've lost the bubble on where Celia is from. But again, this is a group that's working because this area is so ripe for innovation. I talked about the body of knowledge, and I've already talked about aligning the modeling and simulation community under engineering tools and environments. So I don't think I need to brief the slide, but it's in here. If you are already doing this, you understand this. Whether you call it digital engineering or not, I'm telling you, I do not care. What I care about is being able to bring the rigor from a computer, right? At its basic point, you can tell I'm a basic person, right? Not basic the language, but 1 + 1 = 2. It's on or it's off, right? There's no gray area about this. Even in artificial intelligence and machine learning, it still operates off the basic principles of on and off. Think about that, right? Think about the basic capabilities, the rigor that you can now establish. You cannot model what you don't understand. That problem has not gone away. But if you understand it, even to a high level of fidelity or a low level of fidelity, if you understand it and can model it, you can work in this area. So where we are, and I apologize, I didn't leave a whole lot of time for going through the questions. Driving digital engineering transformation through a focus on implementation. That's one of the reasons I'm talking to you. How are you doing it? How are you using it? You don't need to tell me. Tell your customer. Get involved with a group, right? Doesn't need to be the groups that I'm involved in, right? There are lots of groups out there and we're all working in the same area, right? If you find something that's contradictory, tell somebody, right? Get involved. Be a victim of your own success. I challenge you to do that. And I use those words very intentionally. We're working on this community of practice, as I've talked to you about, and you have to have digital practices, right? You can't just drop the old joke about Fred, right? I'll try to shorten it, but an analyst comes to a decision maker and says, hey, look, here's your decision. And he said, what does Fred say? And the guy said, I don't know. I didn't ask Fred. I wrote this model and executed it. And the guy says, well, go back, go talk to Fred. And so the guy goes back to his desk and he renames his model Fred, and then he could answer it affirmatively, right? You don't need to trick your decision maker, but you do need to make your decision maker comfortable. You have to have that ecosystem to work at. An ecosystem and an environment are different things, right? One is populated with tools, the other one is not. I can have a digital environment, but if I don't load, for example, if I don't put any search or any browsers on my tablet, then I'm not sure how much good it's going to be for me to be connected to the internet. Right, so think about the difference there. And then you have to convince your decision makers and make them comfortable. I'll put this slide up because it has my contact information. I have about 30 seconds to go through some of the questions. Let me see if I can come up with one. Thank you on the DBOC compliment. I appreciate that. Communication through, yep, been there a long time. I don't really see any questions. Will there be a link to this document? Oh, and yes, I will pass it on to my son. Thank you very much. I think I'm done, right on time.